All right, let's get right into it. We're about to look at what might be the single most important picture ever taken. It's a snapshot of the universe when it was just a baby. And, hidden right there in plain sight is a cosmic mystery, one that could totally rewrite everything we think we know.
Because that's really what we're talking about here. What if the tiny little imperfections in this baby picture of the cosmos, what if they aren't just random noise? What if they're a message, a kind of blueprint pointing to a whole new kind of physics?
So what is this picture? Well, it's called the cosmic microwave background, or the CMB for short. You can think of it as the afterglow of the Big Bang, this fossil light that tells us exactly what the universe was like only 380,000 years after it all began. And we've mapped this light with incredible, unbelievable precision, thanks to satellites like Planck.
And this is where the trouble starts. See, when we look at all the small details, the little hot and cold spots scattered across the map, our standard model of cosmology, the theory that's supposed to describe the entire universe, it works beautifully. It's perfect. But when we zoom out, and I mean way out, to look at the biggest, broadest patterns in the sky, the model just falls apart.
And it's not just breaking in one spot. Nope. There are 4 major, really stubborn flaws, these anomalies in the blueprint, that have stuck around through multiple missions, multiple analyses, and our standard physics just has no good explanation for them.
Yeah, you heard that right. 4 of them. And these aren't new problems. Cosmologists have been tearing their hair out over them for years.
Okay, so first up, we've got a lopsided sky. One entire half of the universe seems to have temperature fluctuations that are about 7% stronger than the other half. Now, a core idea in cosmology is that the universe should look pretty much the same in every direction. This suggests it doesn't.
Second, there's this enormous cold spot. It's a huge patch of the sky that is just way, way colder than it has any right to be. Some folks thought it might be a giant empty void in space, but the evidence for that is shaky at best. It's a real mystery.
And then we get to the one they nicknamed the axis of evil. And this one is just plain weird. The absolute largest patterns in the CMB, these giant splotches, are lined up with each other. And get this, they're also lined up with the plane of our own solar system. The odds of that happening by chance are so astronomically low, it just feels wrong.
So what's the standard explanation for all this? It's something called cosmic variance. And honestly, it's basically a scientific shrug. The argument is, hey, we only have one universe to look at, so maybe we just got unlucky and we're seeing a couple of statistical flukes. But as the source material points out, 4 of them, all happening at the largest possible scales? That seems like a bit of a stretch, doesn't it?
And this is where a totally new, really radical framework comes into the picture. It says, these aren't flukes. They're not mistakes. They're features. And they're telling us something profound about the universe's hidden shape.
So here is the absolute key difference. The standard model we all use, it assumes the early universe was just this formless, random soup of energy. This new framework, it suggests the complete opposite, that the universe was born with a built-in structure, a kind of primordial grain.
The best analogy is to think of water freezing into ice. As soon as that first crystal forms, it creates a pattern, a grain that directs how all the other water freezes around it. Well, this new idea suggests that the vacuum of space itself crystallized in the first moments of existence, creating a fundamental direction, a shape that we can still see imprinted on the sky today.
And here's the amazing part. This one single idea, this concept of a primordial shape, it could be the key that unlocks all 4 of those cosmic mysteries at once. It's telling us we're not looking at 4 separate problems, but 4 different symptoms of one single underlying structure.
So let's run through our list of cosmic anomalies again, right? We've got the lopsided sky, the crazy cold spot, the axis of evil, and a 4th related problem called missing correlations. The real beauty of this new framework is how this one idea of a primordial grain just might knock them all down in one go.
Okay, the lopsided sky? Suddenly, it's not a mystery. If the universe crystallized with a preferred direction, a kind of handedness, then of course, one side is going to look a little different from the other. This framework even suggests this same handedness could solve another massive cosmic puzzle, why there's more matter than antimatter.
And what about the cold spot? Well, in this new picture, it's not an empty void. It's actually the opposite. It's a spot where the crystallization of space-time was super efficient. It's a deep attractor that bound up so much energy into its very structure that there was less energy left over to radiate as heat.
That's why it looks cold. And the axis of evil, that totally bizarre alignment with our solar system, this framework says it's no coincidence at all. Our solar system didn't just pop up in a random, featureless void. It formed inside this pre-existing cosmic grain, inheriting its alignment from the universe's own fracture lines. We are, in a very real sense, a product of the original blueprint.
And finally, that fourth anomaly. The data clearly shows that patterns bigger than about 60 degrees on the sky don't seem to be connected to each other. In this new framework, that's not a bug, it's a feature. That 60-degree limit is the size of the very first coherent crystal of space-time. It's defining the fundamental scale of the entire universe's geometry.
Now, this is what I find so cool about this. It's not just a cool story. I mean, any good scientific theory has to make predictions, right? It's got to be testable. And this one makes some very specific, very clear predictions that we can go out and check, like, right now.
So let's just focus on the cold spot for a second. If it's really just a giant empty void, it should act one way. But if it's a deep attractor, it should act in a completely different and opposite way. For instance, a void should push galaxies away from it, while an attractor should pull them in. A void should have less gas, an attractor should have more. These are things we can actually measure.
Which brings us to the ultimate test, and it's one we could do with data we already have. It's simple. You measure the motion of all the galaxies surrounding the cold spot. If they're all flowing away from it, then, okay, the standard void idea is probably right. But if they are flowing into it, well, that would be incredibly powerful evidence for the deep attractor and for this entire new picture of the cosmos.
So at the end of the day, this framework completely changes the conversation. These anomalies that have been confusing cosmologists for decades, they stop being errors or random statistical flukes. They become the single most important features in the entire picture. They're the signature of the universe's birth. And that leaves us with one final, absolutely tantalizing question. For years, we've been staring at this message that's literally written across the entire sky, and we haven't been able to read it. Is it possible, just possible, that we're finally starting to figure out what it says?